Welcome back and thank you for joining. We'll continue with finite differences in cubic functions. So what we're trying to do here is analyze how finite differences can help us determine the coefficients in a specific polynomial function. We're looking at third degree this time. And for this, we have selected a third degree polynomial function in standard form. We are looking at the general form of it, and that is because we want to see what connections exist between the coefficients and the finite differences. So we have selected specific values from the domain, making sure that all these x values are changing by 1 unit, so they're increasing by 1 unit. We selected some negatives, some positives, and 0, and obviously smaller values of x, so it's easier and more practical to work with them in simplifying these equations. So we're going to start with the value of y at x equals negative 2. So we're going to say that if x equals negative 2, this function will become a times negative 2 to the power of 3 plus b times negative 2 power 2 plus c times negative 2 plus d. Simplify, negative 2 to the power 3 is negative 8, so that's negative 8a. Negative 2 squared is 4, so that's 4b. Negative 2 times c is negative 2c, and then plus d, so that's going to be the value of y at x equals negative 2. So in a similar way, we'll find the value of y at negative 1. So we have a, negative 1 to the power of 3, b, negative 1 to the power of 2, c, negative 1, and then plus d. We'll simplify. We have negative 1 power 3, negative 1, so that's negative a, and then plus b minus c plus d. Now next we're looking at x equals 0, so we have a 0 power 3, b 0 power 2, c times 0, and then plus d. So this is very easy to evaluate. We know that whenever x becomes 0, the terms that are multiplying it, the entire term will become 0 because the multiplication will result in a 0. So we simply have d as a y value here. Now, if x equals 1, we have a 1 to the power of 3, b 1 to the power of 2, c times 1 plus d. This is another easy evaluation or simplification. However we want to call it in this case, we still have variables. So the reason why is because number 1 to any power will give number 1, which means that we are left with simply the coefficients of the entire equation of a polynomial function. Now we're going to continue with x equals 2, so this would be 2 power 3. This requires a little bit of patience, but it's a fun exercise because it's a simple algorithm and it's a little bit repetitive, and usually these type of processes sharpen our focus and our attention to detail, and also patience, which is very, very important component in learning in general. So this would be the simplified form of y, and now we have x equals 3, we have a 3 to the power of 3, b 3 to the power of 2, c times 3 plus d. And the simplified form of it will be 27a and 9b and 3c and then plus d. So with these y values, which we are going to highlight so it's easier for us to kind of pick them up when we're finding the differences, we will be able to find the first differences. Now, because our expressions, as you can see, are quite long, the first differences will be a little bit of work to show. So here we go. We are going to start with the first differences, which are the differences in the y consecutive y values. And the way we find them is from this y value, we subtract the previous. So I'm going to start off by writing the first y value, which is negative a plus b minus c plus d, and here we're subtracting the previous y value, which is this one here. I'm going to write it down. We're going to keep that in brackets because we are subtracting more than one term, and we want to make sure that whenever we subtract more than a term, the entire expression stays inside brackets to make sure that we are applying the subtraction to each and every term here. So we're going to open up brackets first. And then we have minus negative 8a plus 8a. minus positive b minus 4b, minus negative 2c is plus 2c, and then minus positive d is minus d. So notice how the coefficients d and negative d here will add to 0, and we'll work with the rest of them. Negative a plus 8a, that would be positive 7a. We have positive b minus 4b is negative 3b, and negative c plus 2c is right here, positive c. So this is going to be our first delta 1 in the list of the values that we have selected. And I am going to actually highlight this because it is going to get a little bit crowded in here with all these simplifications. Now, we'll continue with the next set of differences. We have d subtract this expression. So this is kind of shorter, so it's nice that we're getting a break here. Don't you think so? So we have d subtracting, and we're going to keep in brackets negative a plus b minus c plus d. So I'm going to keep inside brackets the whole thing, and that would be d minus negative a plus a minus positive b minus negative c plus c, and then minus d. As you can see again, d plus negative d adds to 0, and in this case we obtain the value of a minus b plus c. So I'm going to write it down here just to have a little bit more space. It's all about space here. Now we're going to continue with the next set of differences. So this time we are subtracting a plus b plus c plus d minus d. So this is going to be again another straightforward sort of simplification, a plus b plus c plus d, and we are subtracting only one term, no need for brackets. You see that d simplifies again to 0, so, or it adds to 0, and what we get is simply a plus b plus c. So that's going to be our difference. Now next we're going to continue with the next one. We only have 2 more to go. We have 8a plus 4b plus 2c plus d, subtract. So we are subtracting the previous expression, which is a plus b plus c plus d. So let's do this quickly. A plus b plus c plus d. And open up brackets, 8a plus 4b plus 2c plus d. Subtract a, subtract b, subtract c, subtract d. And as you can see again, d and negative d will add to 0. And we'll get in here 8a minus a, 7a. 4b minus 1b is 3b, and 2c minus c is equal to positive c. So that's going to be our second last difference we're finding here. And one more to go, and we're almost done for delta 1 for the first differences. So here we go. So this time we have 27a plus 9b plus 3c plus d, and we are subtracting this big expression here, 8a plus 4b plus 2c plus d. Ooh, we made it. Now open up brackets, 27a plus 9b plus 3c plus d, and then subtract 8a, subtract 4b, subtract 2c, and subtract d. As you can see again, we have d minus d equal to 0. And now we'll simplify the rest of the terms. We have 27a minus 8a, or plus negative 8a, same thing, will be 19a. 9b minus 4b is 5b, and 3c minus 2c will be just c. So this is going to be the difference between the last two y values. So next, as you can see here, all these differences are different, and we expect that to happen. We know this is not a linear or a first degree function. So we're going to continue on with the second differences, which are found again in the same way or same fashion. And I'm going to bring them a little bit closer to the edge of the chart in here so that we can zoom in here. Here we go again. We're going to find delta 2. So for delta 2 again, we are subtracting a minus b plus c minus 7a minus 3b plus c. So let's see what happens. A minus b plus c, subtract 7a, subtract negative 3b means plus 3b, and subtract c. Simplify. As you can see here, this time we have c and negative c that add to 0. A minus 7a is negative 6a, and negative b plus 3b will be equal to 2b, or not to be. All right, so here we go. We're going to go ahead and find the differences between the next delta 1 values. Again, same idea. We have a plus b plus c, subtract a minus b plus c. Let's see what we have cooked here. A plus b plus c minus a minus negative b is plus c minus positive c minus c. Again, same pattern repeats. As you can see here we eliminated all the d's, now all the c's. So, and that's the way it works, right? So there is magic in this kind of patterns in finite differences, and that's the one that we're experiencing so far. So we'll summarize them later. So we have a minus a, so that would be 0a, and we are left simply with 2b here. Surprise, surprise. So these two simplified as well in this case, so we have 2b. Now, why don't we highlight them actually? So I'm gonna choose a little bit of a different color here. So I'm gonna choose yellow. Okay, now next we have the difference between these differences. So 7a plus 3b plus c, and then subtract a plus b plus c. So let's see what happened. 7a plus 3b plus c, subtract a, subtract b, subtract c. So again, as you can see, we are losing in here our coefficient c. So c plus negative c will add to 0. And we're going to say that 7a minus a will give 6a, and 3b minus b will give 2b. Now, you probably notice the pattern starting to appear in here, and this will be our last second difference that we have to find. And we see that we have 19a plus 5b plus c, subtract 7a plus 3b plus c. So open up brackets, 19a plus 5b plus c, subtract 7a, subtract 3b, subtract c. Again, same idea. We are losing the coefficient c. It simplifies to 0. And 19a minus 7a, that will be 12a, 5b minus 3b would be equal to positive 2b. So this would be our last one here. And as you can see, the second differences are not constant. So let's make a point in here. So they're different than a constant. That's expected, but let's make a point different than a constant. And let's see what luck we get with the third differences. So I wanted to guesstimate in your head, but we're gonna complete the, perform all the calculations in the meantime. So we're gonna find delta 3, same idea. So we have 2b, subtract the previous difference, which is negative 6a plus 2b. So 2b minus negative 6a is positive 6a, minus positive 2b is minus 2b. So as you can see now, it's time for b to go, and b is quietly leaving the expression. The difference is here, and we have 6a as the difference between these two second differences. Let's continue with the next set. We have 6a plus 2b, and then subtract 2b. We don't need brackets. We're subtracting only one term, so a monomial. And you see again that we have the two b's simplified to a 0, and we get 6a as delta 3 for this pair. And one last difference, we have 12a plus 2b, and we are taking away 6a plus 2b. So let's put it here, 6a plus 2b, and we got 12a plus 2b minus 6a minus 2b. You see again, same idea, the b's are gone. 12a minus 6a is equal to 6a, and we're going to take a closer look now at our third differences and see what we got. We got 6a, 6a, 6a. They're all constant, they're all the same, so we're going to say that delta 3 is constant. And delta 3 is constant thanks to the fact that this is a third degree polynomial function. So conclusion number 1 that we will be drawing here is that in polynomial functions of third degree, delta 3 is constant, and that is related to the fact that this is a third degree polynomial function. Now, other things we need to find out and investigate in here is how is the third difference related to the coefficients, because when we use the table of values to find the equations, it means that we need to find these coefficients. Those coefficients make each polynomial equation of third degree unique in a way. So we need to find out if there are any patterns between the differences and all these coefficients, or in other words, where can we find these coefficients in all this work that we have done here? So as you can see, delta 3 is equal to 6a, and we derive this from a general form of the equation, so that is going to work whatever the a value in a specific or unique equation is. So we're going to say if delta 3 is 6a, then we're going to use this to determine the value of a. So we're going to say a would be delta 3 divided by 6. Or in other words, we say that it would be 1/6 of delta 3, right? Now, the next coefficient that is easy to identify in our case will be the constant term. Now, the constant term is always found when x equals 0 because it's not dependent on x. When all these terms disappear, this one is going to stand here. And we get this from the table of values, just like we did with quadratic and linears. So when x equals 0, we're always going to get our d coefficient. And we're going to make a note in here so that we remember that to find the coefficient d, we have to look at the y value, because that's what it equals, at x equals 0. And where do we get that from? We're going to use for this the table of values. Now, if in the table of values you're not given x equals 0, then you have to work the function backwards until you hit that value of y when x equals 0, or until we hit 0. We're going to do an example together. So we have the coefficients a and d. So what do we do about b and c? Now remember that in quadratic functions we had one extra coefficient we had to find besides a and the constant, and for this we used an ordered pair from the table to figure out the coefficient. Now because we have two coefficients in this case, we're going to use the same strategy, but instead of using just one ordered pair, we're going to have to use two ordered pairs so that we can figure out two more unknowns to this equation. So I'm going to make a note in here, and I'm going to make this note a different color. So to find coefficients b and c, we're going to use two pairs or two order pairs of values from the table, from the given table. And usually I would like to choose the value when x equals 1 because it's an easier order pair to work with, and when x equals 2, because why not? So when x equals 1 and when x equals 2, because these are the smaller numbers and they're positive. Now, can we use x equals 0, y equals d? Not really, and that is because we already used this for coefficient d, so we cannot use it to find the other coefficients. So the equations will give us no solution. So let's jump into an example. So we are given a table of values. We have to find the equation of each function. So we're going to start with the first one, obviously. But before we start, I just want to remind you that whenever you actually work on these type of questions, you will want to check the x values, whether or not they are listed in order and whether or not they differ by 1 unit only. If they're increasing by 1, that is important. And once you make sure that's what it is what we need, so we can start off with finding the differences. So what we have in here is negative 13 minus negative 48. So negative 13 minus negative 48. So when you find negative 13 minus negative 48, we're going to get the value of 35. Next, we have negative 2 minus negative 13. So that's negative 2 plus 13, and negative 2 plus 13 equals 11. Next, we have 0 minus negative 2 minus negative 3 minus negative 2. So negative 3 minus negative 2. So let's do these little arrows in here to keep us focused. Negative 3 minus negative 2 is negative 3 plus 2. That will give a negative 1. Then we have negative 4 minus negative 3. So that's negative 4 plus 3, negative 1 again. And then next we have 7 minus negative 4. And that's 7 plus 4, that's 11. Now, obviously, the first differences are not constant, which tells us that this is not a linear function. So we'll continue with the second differences. So 11 minus 35, negative 1 minus 11, negative 1 minus negative 1, and 11 minus negative 1. Let's see how this works. So we have 11 minus 35, and 11 minus 35 will give negative 24. Next, we have negative 1 minus 11. That's a negative 12. And now we have negative 1 minus negative 1. That will give us negative 1 plus 1, or 0. And 11 minus negative 1 would be equal to positive 12, so 11 plus 1. As you can see, delta 2s are also different than a constant number, so it's not a quadratic. So we'll move on to the third differences. So for third differences, we have negative 12 minus negative 24. So that would be negative 12 plus 24 equals 12. Then we have 0 minus negative 12. 0 minus negative 12 will be also positive 12. And lastly, we have 12 minus 0, which is also equal to 12. You see that delta 3 is a constant number. It is equal to 12, which tells us that this is going to be a polynomial function of third degree. And the equation of it will be in the form y equals ax cubed plus bx squared plus cx and then plus d. So let's check and see what coefficients we can find. So we know that we can find the coefficient a as 1/6 of delta 3, and delta 3 being 12 will give us the coefficient a of 1/6 times 12, so a equals 2. Next, we're going to find the coefficient d. Coefficient d is the y value of the function when x equals 0. And when you look at the graph in here, at the table of values, at x equals 0, we have the y value of negative 2. This is going to be our constant term of negative 2. So what that means is that we're now ready to get to the coefficients b and c. That's what we're missing. So first we're going to write the equation that we have created. So this would be y equals 2x cubed plus bx squared plus cx and then minus 2. So we're going to use this equation to find b and c. We're going to need two ordered pairs, and the ordered pairs that we'll be using are 1 and negative 3 and 2 and 4. So when x equals 1 and y equals negative 3, we're going to have negative 3 equals 2 times 1 power 3, b times 1 squared, c times 1 minus 2. So we're going to simplify this. We have negative 3 equals 2 plus b plus c minus 2. So 2 and negative 2 will simplify here to 0. So we have created the first equation that describes the relationship between b and c, and b plus c equals negative 3. We're going to need a second equation to figure out the second unknown. So when we have two unknowns in an equation, we're going to need two equations to solve it and put them together in a system. So we're using this time point 2 and negative 4. So x is equal to 2 and y will be equal to negative 4. And that will change up our equation to become 2 times 2 to the power 3 plus b times 2 to the power 2 plus c times 2 minus 2. So negative 4 equals 16 plus 4b plus 2c minus 2. So we have negative 4 equals 16 minus 2, which is 14 plus 4b plus 2c. Again, you can do this a lot faster. I just don't want to miss or lose anyone in the process of solving this. So we have negative 18, take 14 to the other side, and equals 4b plus 2c. Now it is best to simplify these equations before we use them in the system of equations, and we can because all the coefficients are even numbers. So we have 2b plus c equals negative 9, and here we created a second equation that has contains the variables b and c. So we're going to bring together the two equations. So I'm going to call this the equation A, and I'll call this the equation B. And I will bring them closer to each other. So 2b plus c equals negative 9. So this would be our equation B. And as you can see here, we have the same coefficient for c, which means that we can solve this system of equation by using subtraction, elimination method with subtraction. So we have b minus 2b, and then plus c minus positive c equals negative 3, and then minus negative 9. And now we have the two c's that simplify. We expect that to happen. And b minus 2b is negative b, and negative 3 plus 9 is 6. That will make the b value equal to negative 6. And if b plus c is negative 3, then we're going to say that negative 6 plus c is negative 3, which will make the value of c equal to positive 3. So with this, we have also discovered the values of b and c, and we're ready to put them all together in the equation, and we will have the equation of this third degree polynomial function expressed in the form. You see a is equal to 2, and then we have x cubed with b value of negative 6, x squared, c value is equal to 3, so we have 3x, and the constant term, which was negative 2. And this would be the final answer to this problem. And let me just make this a tiny little bit smaller. And this is the end of it. There is another example that you can look up on your own if you wish. And we have a table of values in here. It's very similar to what we just did. We're going to do this a little bit faster. So what we have in here is x values between negative 2 to positive 3. And we are going to find the first differences. we have 8 minus 11. That's negative 3. 3 minus 8 is negative 5. 2 minus 3 is negative 1. 11 minus 2 is 9. And 36 minus 11 is equal to 25. Now we're going to do second differences. Negative 5 minus negative 3, negative 2. Negative 1 minus negative 5, that's going to be a positive 4. 9 minus negative 1, that's a 10. And 25 minus 9 is equal to 16. So again, second differences are not constant. Let's check the third differences. We have 4 minus negative 2 is 6. 10 minus 4 is 6, and 16 minus 10 is also 6. So that will give us the value of A, which is 1/6 of delta 3. So 1/6 of 6 is going to be 1. The value of D is going to be equal to 3. So the equation is in the form 1x cubed plus bx squared plus cx and then plus 3. So we're going to use the ordered pair right here. We're going to choose 1 and 2 and 2 and 11. And we're going to take it from there. And we are going to substitute 1 and 2 first. So x equals 1 and y equals 2. And in the same way, we are going to substitute x equals 2 and y equals 11 as well. And here we go. We have x equals 2 and y equals 11. Let's see how this goes. So we have 2 equals 1 plus b plus c plus 3. And that will give b plus c plus 4 equals 2. So b plus c is equal to negative 2. Next, we have the second equation, which is 11 equals 2 to the power of 3 plus b times 2 to the power of 2 plus c times 2 plus 3. So that would be 8 plus 4b plus 2c plus 3. So 11, 8 plus 3 is 11, so subtract from the to the other side 4b plus 2c. So 0 equals 4b plus 2c, or simply we're going to say 0 equals 2b plus c. So we're going to put the two equations together so that we can solve. So we have 2b plus c equals 0. And that means that by elimination, we're going to have b minus 2b, negative b, c minus c is 0, negative 2 minus 0, negative 2. So the value of b is 2, and the value of c is 2 times 2 plus c equals 0, so we get c equal to negative 4. So far we got the values of b, the value of c, we got the value of a equal to 1, and the value of constant term 3. So the equation will be f of x, equals, we have x to the power of 3 plus 2x to the power of 2, b is 2, minus 4x, that's for c, and then the last term, which is positive 3. And that would be the equation, and it was found just by using the finite differences and the table of values. So this is the end of this lesson, and of lesson 4. You have a lot of practice again, as always, so please practice as much as you can. And as always, thank you for learning with me on. Bye for now.